In this video, we're going to review zero negative exponents that you learned about in grade 10. First, we're going to look at their meanings, what they represent, by looking at the patterns that we see when we evaluate powers of 2 and 3. So starting with powers of 2, we have 2 cubed, which is 2 times 2 times 2, or 8. And we have 2 squared, which is 4. And then 2 to the 1, which is 2. So as the exponents decrease, what's happening to the numbers on the right-hand side as we go from one row to the next? Well, we're dividing by 2. So if we continue to divide by 2, we'll get an answer of 1 when we have 2 to the exponent 0. The same is true when we use powers of 3. 3 cubed is 27, 3 squared is 9, 3 to the 1 is 3. As we go from one row to the next, we're dividing by 3. So 3 divided by 3 would also give us 1. We have 3 to the exponent 0. So any number raised to the exponent 0 other than 0 is equal to 1. Now if we continue looking at the meaning of negative exponents and following the pattern, the next number here would be 1/2. So 2 to the exponent negative 1 is 1/2, since 1 divided by 2 is 1/2. And then 2 to the negative 2 would end up being 1/4, since 1/4 divided by 2 is 1/4. Now these fractions can be written as powers of 1/2. So 1/2 is just 1/2 to the exponent 1, and 1/4 is 1/2 to the exponent 2. So what we see here is that powers with negative exponents really represent fractions, and we don't like writing fractions, so we utilize negative exponents a lot when we're writing out expressions. But to evaluate without a calculator, we need to rewrite powers negative exponents using positive exponents. So that's going to be what we need to be able to do in grade 11. Now, if you notice, to go from powers with negative exponents to powers with positive exponents, all you have to do is take the reciprocal of the base. So in this case, the base of 2. The reciprocal of 2 is 1/2. And then you change the exponent from a negative to a positive. Okay? So let's take a look at this question here. Example 1 says evaluate. And this one is already done because 10 to the exponent 0, that's really easy. It's equal to 1. Any number raised to the exponent 0 is 1. The next one, 5 to the exponent negative 3. So if we are going to evaluate this without our calculator, we need to first rewrite it using positive exponents. So to do that, we take the reciprocal of the base, and the reciprocal of 5 is 1/5, and then change the exponent from a negative 3 to a positive 3. And then we can apply the power of a quotient rule by multiplying the inside exponents by the outside exponent of 3 to give me 1 cubed over 5 cubed. And then evaluating the numerator and the denominator, I get 1/125. Okay? Now, some students, after they do a lot of these questions, notice that 1 cubed over 5 cubed is 1/5 cubed. Okay, and so when they compare the power with the negative exponent to this, they just notice that rewriting using positive exponents can be done by simply taking the reciprocal of the entire power. So if this power is written as a fraction with a denominator of 1, you would simply take the reciprocal of that and change the exponent from a negative to a positive, while skipping the intermediate steps. So that can be done when your base is an integer or whole number. Okay, another way to think of it is that you're changing the position of the power in the fraction. So before it was in the numerator, now it's going to be in the denominator, and the exponent will be positive. So if I look at C, I have -4 to the exponent -2. I can take the reciprocal of this entire power to give me 1/-4. And then I would change the exponent from -2 to a +2. And then evaluating -4 squared gives me +16. In part D, the entire power is negative, so I will have a negative to start. And then I'm going to rewrite 3 to the exponent -4 using positive exponents by taking the reciprocal of the entire power. So I would rewrite it as 1/3, and then change the exponent from a -4 to a +4. And then evaluating 3 to the exponent of 4, I get 81. Here, because the base is a fraction, I would need to take the reciprocal of the base. I can't take the reciprocal, well, I can take the reciprocal of the entire power, but then it's going to be more work to get the answer. So I'm going to take the reciprocal of the base, which is 3/2, and change the exponent from a negative to a positive. Then I'm going to apply my exponent rule for a power of a quotient to give me 3 cubed over 2 cubed. And evaluating gives me 27/8. Okay, here's some other examples that I'd like to do here. So here it says evaluate expressions, evaluate and then express answers in rational form. And so that means the answer should be left in fraction form. So the first one that we're going to look at is 3 to the 5 times 3 to the exponent -2 all over 3 cubed squared. Okay, so there's more than one step involved because I have to simplify the numerator first. If I'm multiplying powers with the same base, I'm going to add their exponents. So 5 and -2 when added together gives me 3. In the denominator, I have a power of a power, so I'm going to multiply the exponents of 3 and 2 together to give me 6. Now I'm dividing powers, so I'm going to subtract the exponents to give me 3 to the exponent -3. I ended up with a negative exponent, and for me to evaluate that without a calculator, I have to rewrite it using positive exponents. So I am going to take the reciprocal of the entire power and change the exponent from a negative to a positive. And then 3 cubed, when evaluated, gives me 27. So the final answer would be 1/27. The next one, I have 4 squared times -2 to the exponent -5. Okay, so you can treat this as a whole fraction if you want, and this is the only one, that was the only power with a negative exponent. I only have to take the reciprocal of that. So 4 squared will still remain in the numerator, but the reciprocal of -2 to the exponent -5 is -2 to the exponent -5, but then I would change the exponent from a negative to a positive. Okay, so you're changing the position of this power in the fraction because the exponent is negative. And then you evaluate. 4 squared is 16, and -2 to the exponent of 5 is -32. And make sure any rational numbers that you get, you write in lowest terms. So dividing both numerator and denominator by 16, you get a final answer of -1/2. Okay, and then C, we have -3 to the exponent -5, and we're dividing by 9 to the exponent -1 squared. Okay, so I'm going to simplify the denominator first by multiplying the exponents. And now because both of the powers have negative exponents, I have to change their positions in the fractions. So by doing that, I'm actually taking their reciprocals. So -3 to the exponent -5 will now appear in the denominator with a positive exponent, and 9 to the exponent -2 will appear in the numerator with a positive exponent. And then we evaluate. 9 squared is 81. -3 to the exponent 5 is going to give me -243. And both numbers 81 and 243 are divisible by 81. So in those terms, I end up with an answer of -1/3. And then the last one, I have 5 to the exponent -2 multiplied by 4 to the exponent -2 over 2 to the exponent -5. So you can write your answer as one big fraction. Okay, just take note that all the powers are negative, have negative exponents, so you have to change their positions in this big fraction. So 5 to the exponent -2, when you take its reciprocal, will end up in the denominator, and then you change the exponent from a -2 to a +2. Okay, 4 to the exponent negative 2, it's in the numerator. And so you're going to change its position to the denominator and change the exponent from a negative to a positive. And 2 to the exponent negative 5 is in the denominator. You're going to change its position, move it to the numerator, and the exponent will become positive 5. And then you evaluate. So 2 to the exponent 5 is 32. 5 squared is 25. 4 squared is 16. Okay, now remember, we're trying to do this without our calculator, so here you simplify first before you multiply. So 32 over 16 is just 2. And you end up with 2 over 25, because both of these can be divided by 16, okay? And that's the final answer.